Number 1, Milton has his money invested in a stock portfolio. The value of E of x of his portfolio can be modeled by this function, where x is the number of years since he made his investment. Which statement describes the rate of change of the value of his portfolio? So we have an exponential function here. Hopefully you recognize he starts with $30,000, and this 0.78 has to deal with the percent rate of change. How did we get that 0.78? Well, we did 1 minus the percent. So clearly it's decreasing. Clearly the percent is decreasing because this number is smaller than 1. Well, he's keeping 0.78. He's keeping 78% of it. So what is he losing? Well, what's 100 minus 78? 100 minus 78 gives us it decreases by 22. So when we deal with these decay models, we do 100% minus whatever percent is represented by that decimal there. A student invests $500 for 3 years in a savings account that earns 4% interest. So my initial value is 500. 3 years is going to be my exponent, 4% interest. So he's growing money. I'm going to do 1 plus. What's 4% as a decimal? What's 4 over 100? That gives me 0.04. So which of these expressions, which statement does not? So many of you today circled number 1 because it looks right. And number 1 does give us the value. It does yield the correct value, but I want which one does not. Those two are the same, so that's fine. Those look like the same because an exponent is repeated multiplication. Number 4 might look weird to you, but number 2, there should be a bigger red flag that we're doing 1 minus. This is exponential growth, not exponential decay. Number 2 represents decay, so that has to be wrong. What is the largest integer x for which the value of f of x will be greater than the value of g of x? So which of these values will f be bigger than g? What's the biggest integer for which that works? So making a table would be great here to see which one's bigger. If only we had a way to use our calculator to make a table. We do. So in y1, let's put in the f function, and in y2, let's put the g function. So now that I have these both typed in, I can go to my table. Well, that's too far up. And see when is f bigger than g is what I believe the question wants. And copy that table down onto your paper if you choose. Went too far. Copy that table down onto your paper. 7, 8, 9 is what I need. So the question says, what is the largest value for x when is f bigger than g? What is the biggest value for when f, which is y1, bigger than g? 7, 8, it's still bigger. 9, it's still bigger. 10, though, the second function's bigger, so 9 is the answer. 9 is the largest value because at 10, g wins. G is bigger. Exponential functions will always outpace everyone else. They eventually will get bigger than everyone else. Which function is shown in the table below? Whenever you say, here's a bunch of functions in a table, which ones match up, use your calculator, is all I'm going to say. Plug this into y1. Does the table check? No. Plug this into y1. Does the table check? No. Plug this into y1. Does it check? No. Choice 4 does check. Take each choice, plug it into y1, and see what matches up. The range of this function. When you see the word range, you need to think of y values, my outputs. And if you were to graph 5 to the x on your calculator, you would get a shape that looks like this nice exponential curve. Well, the lowest y value I get, well, I never get 0. I never get 0 because, remember, it just keeps getting closer and closer and never goes to 0. And I want less than 0 or bigger than 0. Do I want positive y values or negative? I want positive, so choice 2. Ranges your y values. We talked about this one in class, of how equal differences over equal intervals means a linear function. Equal factors over equal intervals would mean an exponential function. Equal differences means linear. Choice 1 is linear because it grows at a constant rate of 3.5 centimeters per day. Choice 2 is exponential because it loses 15% per year. That's exponential. And if something triples, that's also exponential. So only one was linear. Determine whether t is linear or exponential. So let's see if I have a constant average rate of change. To see if it has a constant average rate of change, we look at the slope. Minus 2.5, minus 2.5, minus 2.5, minus 2.5. That's my change in y, which appears to be constant. Our change in x is plus 2. So it does have a constant average rate of change. Linear, explain means write a sentence, because it has a constant average rate of change. If it didn't have a constant average rate of change, we'd go with exponential. Don't try to find the multiplicative pattern, see if it's linear. If not, we would have went with exponential. A laboratory technician studied the population growth of a colony of bacteria. He recorded the number of bacteria every other day as shown in the partial table below. Which function would accurately model this data? Well, I have 4 functions in a table. How can I see what works? How can I see which function would model the data? Use your calculator. Plug it into y1, see if it matches. Plug it into y1, see if it matches. Be careful. Look at your x values. Your t values are 0, 2, and 4. So your table is going to go 1, 2, 3, 4, 5, but you only want to look at 0, 2, and 4. It comes out to be choice 2. The function v of t represents the value in dollars of a comic book T years after its purchase. You should look at this and say the initial value is $13.50, and we want to know what's the yearly rate of appreciation. What's the percent rate of change here? Well, 1.017 means it's growing because this number is bigger than 1. The decimal is 1.017. That's the percent as a decimal. So I'm going to multiply that by 100 to get it back into a percent and get 1.7%. Too far. Crystal was given $3,000 when she turned 2 years old. Don't question why the 2-year-old was given $3,000, just move on. Luckily, her parents invested it at a 2% interest rate compounding annually. No deposits or withdrawals were made. Which expression can be used to determine how much money she had? Well, she's gaining interest, so I'm going to get rid of the decay models. I don't need the minus signs there. I want it to grow. Well, the only difference is the 16 or 18 years. Well, you might say, well, she turned 18, but she got the money when she was 2, so she only got interest 16 times. It only happens 16 times, that 2% growth. So that's why it's choice 1. The value of a certain car after X years is modeled by this equation. How much more money is the car worth after 2 years than 3 years? You should look at this and say the initial value is 25,000. What's the percent rate of change? 100 minus 86 is 14%. That has nothing to do with the question they're asking, but still using that model is important. How much more money is the car worth after 2 years than 3 years? So find V of 2, find V of 3, and then subtract them. Be careful though, because V of 2 is right there, V of 3 is right there, and when you subtract them, you end up getting choice 1. So choice 1 is the answer, but you need to plug in a 2, plug in a 3, and those are right there. Luckily, don't pick those choices. You're not done yet. You need to subtract the 2 of them. The table below represents the function f. Which equation, the equation that represents this function is, I give you a bunch of functions and say which one fits this table. Use your calculator. Plug them into y1 and check. I believe the answer is choice 1 here. Not choice 1, choice 3. 2 to the x plus 1. You plug it in, see if it checks. Notice that it skips 5. It goes 3, 4, 6, 7. So make sure you're checking that. Be very careful. The breakdown of a sample of a chemical compound is represented by the function p. So it's exponential. How do I know it's exponential? The variable's up in the exponent. Explain what the 0.5 and the 300 represent. The 300 is the initial amount of substance, the initial amount of substance that we had, the initial amount of milligrams. The 0.5 is the decay factor, the decay rate. Well, 0.5, 100 minus, this is 50%, it's losing 50% each t is year. That's what that represents. So the initial value was 300, the y-intercept was 300, and I'm losing 50% each year. I noticed that I skipped Rachel and Mark, so flip on back to Rachel and Mark and find them. Rachel and Mark were given information about bacteria growing in a petri dish. Here's a table. Rachel wants to model this with a linear function. Mark wants to use an exponential function. Which model is a better choice? Well, let's see if a linear function would make sense. That's plus 60, plus 70, plus 90, plus 110. This is getting crazy. Plus 140. I'm going to stop right there. Rachel is not going to work. We do not want to use a linear function because it doesn't have a constant average rate of change. So if my only option are Rachel and Mark, I'm going to go with Mark and exponential. Explain why this data does not have a constant average rate of change. There is not a constant average rate of change. So because it wasn't linear, and my only choice is linear or exponential, I'm going to go with the exponential function here. Hopefully you found this helpful. Good luck studying tonight.